All right, welcome to The Explainer. You have probably written a Python for loop thousands of times. I mean, it's second nature, right? But have you ever stopped to wonder what's really going on under the hood? Well, today, we're going to pull back that curtain and reveal the clever secret that makes it all work.
Okay, so let's just dive right in. You type for item in my list maybe a million times a day without even thinking about it. But what is Python actually doing in the background? What's the hidden machinery that makes that simple line of code work so perfectly every single time?
So the whole secret, the key to the entire for loop, really just boils down to a single, really powerful concept. It's an object that doesn't just drive loops, it's also the key to some of Python's most memory-efficient and powerful features.
And that concept is the iterator. Now, the textbook definition is that it's an object representing a stream of data. Its only real job is to hand you items from some collection, one by one, and only when you ask for them.
Yeah, I know. Stream of data sounds a little abstract, right? So let's use a much better analogy. Think of an iterator as a lazy bookmark. Seriously, it has no idea about the whole book, it only knows its current position and how to get to the very next page. That is it.
And what's so cool about this lazy bookmark is how simple it is. It follows this very specific, very simple protocol. It only needs two commands to do its entire job, and these two commands are the foundation for pretty much all iteration in Python.
Okay, so first up, you have the built-in iter function. You call this on a collection, like a list, and that's what gets you the bookmark. Then you have the next function. You call that on the bookmark itself to get the current item and, move the bookmark forward one page.
Let's actually see this thing in action. We've got our list of numbers. First, we call iter on it to get our iterator object, our bookmark. Now, the first time we call next on it, boom, we get 1. We do it again, the bookmark moves, and we get 2. See how we're in total control here? We're manually stepping through this thing, one item at a time.
So, what happens when you get to the end of the book? If you try to call next after you've already gotten the last item, the iterator raises a special error called stop iteration. Now, this is super important. This isn't a bug. It's actually a signal. It's the iterator's way of saying, hey, I'm all done here, there's nothing left.
All right, pop quiz time. Let's see if this is sinking in. We create two separate iterators from the exact same string. Then we call next on them in this specific order. What do you think is going to print out? Go ahead, pause and think it through for a sec. Okay, if you guessed A, B, you got it. And this really drives home a key point. Every single time you call iter, you get a brand new, totally independent bookmark. Moving one forward has absolutely no effect on the other one. All right, so now we have all the pieces of the puzzle, right? We've got the iter function to get the bookmark, the next function to move it along, and that stop iteration signal to tell us when to stop. So let's put it all together and finally see the magic.
And here it is. This is the big reveal. On the left, you see the simple, clean for loop we all know and love. But on the right, that's what Python is secretly translating our code into behind the scenes. It's actually a while true loop that manually creates an iterator, repeatedly calls next to, and then uses a try except block to catch that stop iteration signal, just so it knows when to stop.
So just to break that down, this four-step dance is happening automatically with every single for loop you write. First, Python grabs the iterator with iter. Then it kicks off a while loop that just runs forever. Inside that loop, it calls next to get an item. And finally, it's just waiting for that stop iteration error so it can break the loop. That's the whole protocol.
Okay, another quick gut check for you. Based on everything we just saw, what is the absolute first step Python takes when it sees that line for item in my list?
Yep, it's got to be B. Iterate my list. You can't ask for the next page if you haven't even gotten the bookmark first, right? Makes perfect sense when you think about it that way.
Okay, so you might be thinking, this is cool trivia, but why does it actually matter? Well, it turns out this is way more than just trivia. Understanding this secret is what separates good Python code from great, really efficient code.
And it all really comes down to two huge takeaways. First, this whole system is incredibly memory efficient. And second, it introduces a major pitfall, a gotcha, that you really have to watch out for. These iterators are single use only.
Let's talk memory. Because the iterator only ever holds on to one item at a time, just the next one. You can process gigantic files, or stream data from an API, or read a database query without ever loading the whole thing into memory. It's an absolute game changer for big data.
But here's that pitfall I mentioned. Once that bookmark hits the last page of the book, It's stuck there. The iterator is now what we call exhausted. You can't rewind it. You can't loop over it a second time. It's a one-way street, and that trip is over.
All right, let's really put that idea to the test. Check this out. We make an iterator from the word cat. We manually call next on it twice. Then, we take that exact same iterator and drop it right into a for loop. What's going to happen?
And the answer is C. We see C, then A from our manual calls, and then just T from the loop. And this is so important to get. The for loop didn't start over. It just picked up the very same bookmark right where we left it and kept going until it was finished. All that was left was T.
And that really brings us to the final, super important distinction, the difference between an iterable and an iterator. An iterator, that's your list, your string, it's the thing that can be looped over. Think of it as the book. The iterator, on the other hand, is the object that actually does the looping. That's the bookmark. You can get lots of bookmarks from one book, but each bookmark can only be read through once.
You know, what we've dug into today isn't just some weird Python quirk. It's a really elegant and fundamental piece of the language's design for handling data efficiently.
So the next time you write a simple for loop, you'll know about the secret life happening underneath. And that just leaves one last question. What other simple, everyday code is hiding this kind of incredible engineering, just waiting for you to discover it?